Hello, so we're going to start on chapter 11 today. We'll start with reviewing over ratios and proportions. You've definitely done this before. An expression that compares two quantities with division is considered a ratio. So while ratios can be written in a variety of ways, for our purposes, we are going to just stick with fractions. But if you recall, you can write it with the word 2 between them. You can write it with a colon between them. And then the first number is always the numerator of the fraction. And really, it's most useful to use a fraction form for our purposes. Proportion is an equation of two ratios. So you have two ratios with an equal sign between them. For example, 2/4 is equal to 3/6. That is a proportion when you have that equal sign between the two fractions. Okay, you probably recall from last year that we use cross multiplication to solve for variables in a proportion. Now, it does make sense that we do that. I'll just write a little quick example over here. So let's say we had, actually, let me do a different one. Let's do one that's easier. So let's say that I had x over 2 is equal to 12. So if I want to get rid of that 2 in the denominator, you multiply both sides by 2. Okay, and that cancels out the 2, and then you get, obviously, x equals 24. You actually use that same logic when you do cross multiplication. So here, notice that I'm solving for x. I have that equal sign. Whenever I have the equal sign between the fractions, that's when I'm going to cross multiply. So it makes sense because you're going to basically take this x and multiply both sides by x. And that leaves an x up here. You're going to take this 7, multiply both sides by 7, and that creates a 7 multiplier over here. Okay, but what you probably remember from last year is your teacher may have done something like this, where you just kind of circle the cross multiplication, and then you just rewrite a new equation. So 5x should be equal to 28. Divide by 5 on both sides, and you do get 28 over 5. And as always, that is a perfectly fine answer. Okay, when you have, again, you have that equal sign between two fractions, so we know we're going to cross multiply. But when you have adding or subtracting within the fraction as well, you want to make sure you put parentheses. Okay, because when you cross multiply, you are going to have to distribute. So here I would get 4 times x plus 5, and then 2x plus 4. Okay, so pause for a second and solve that. Okay, welcome back. I'll do this really quickly. So you distribute the 4 and the 3, and then move some x's around. So that's 2x, move that over here, that's 8, and then divide by 2. So you should get x equals 4. Okay, another always good idea is just to double check that that makes sense in the equation. So if I plug in the 4, I get 3 over 9. And if I plug in the 4 here, 8 plus 4 is 12. Both of those are equal to 1/3, so that checks out. Okay, number 3, again, we have that equal sign between the fractions, so that's when you cross multiply. We have plus signs here, so I'm going to put parentheses. And then we're going to cross multiply. What you're going to notice is this is going to be a quadratic. Okay, 4 times 3 is equal to 12. You are going to have to FOIL and then move the 12 and then refactor. You can't just get answers from here because it's not set to 0. Okay, so pause and try that on your own. Okay, welcome back. So when I FOIL this, I get 6x in the middle and then 5 equals 12. Subtract the 12 and then refactor. Okay, so 7 and a 1 with a plus and a minus. Set each of those equal to 0 and you get 1 or -7. Now, if this is not within a geometry context, you are going to keep both answers. So both of those answers are going to work in the algebra equation. You only have to check if the answers work if you were given side lengths or angle measures that you would have to, then you would have to do a little more work. But if it's just an algebra equation, both of those should work. Okay, the next thing, so definition of similarity. So similar polygons, here's the notation for similarity. So congruence, remember, was an equal sign with the squiggle. Similarity is just the squiggle. So two polygons are similar if their vertices can be paired such that. So first thing, the corresponding angles are still going to be congruent, just like they are with congruency. The only difference here is the side lengths are proportional. So you can set up proportions for all the corresponding sides, or ratios that are equal. We use a similarity statement to establish similarity between polygons and to also indicate which angles and sides are corresponding. So this down here is an example of a similarity statement. Okay, so that's a similarity statement. And you'll notice it does look very much like a congruency statement, except you have that similarity symbol instead of congruence. Okay, and the statement actually acts just like a congruent statement in that the first letter in this name corresponds with the first letter in that name. So we can set up our corresponding angles as congruent. So angle A is congruent to angle E, angle B is congruent to angle F, and so on. And then the difference is that you set up your corresponding sides in an extended proportion. So this is called an extended proportion. So when you have more than just two ratios set equal to each other, that's an extended proportion. Okay, but you'll notice, so AB, the fraction AB over EF is the same as BC over FG, and so on, to create that extended proportion. Okay, another thing that is not written here, so I'll just have you write it off to the side here, but there's a thing called a similarity ratio. And what that is, so for example, let's say that AB is equal to 5 and EF is equal to 3. So AB and EF correspond. So the similarity ratio from the red to the blue, right? This is the red, this is the blue. From red to blue would be 5 to 3, or in other words, 5 to 3. Okay, now if this statement was flipped, you would flip the numbers. So if I was going from blue to red, I would say 3 to 5, and then 3 to 5. So the order of the similarity ratio does matter. You just got to keep that in mind. Okay, so let's try some of these. For each example below, determine if the polygons are similar. Justify your answer, and if they are similar, write the similarity statement. So remember, there's two parts to proving similarity. The first is, are the angles congruent? You have to know that the angles are corresponding angles are congruent. Well, looking at the markings, these are congruent, these are marked congruent, those are marked congruent, and those are marked congruent. So that would be a yes, right? So the markings tell us that piece. And then you'd have to prove that the sides are proportional. Okay, so the second part is a little more work. So you want to know which, without a similarity statement, we are not sure which sides are corresponding. So you can look at the angles marked to tell. So here's the one curve and the two curve. So this 2 would have to correspond, there's the one curve and the two curve with this. right? So that's going to be a 2-to-1 ratio. Okay, going around, so 2 curve to 3 curve, then this is with this. So that's going to be 6 to 3. And then this will be 3 to 1.5. And then here would be 4 to 2. Okay, now you can just reduce all of those fractions, but they all reduce to just 2 or 2 over 1. So that shows that the sides are proportional. Okay, so we've just proven that these two polygons are similar to each other. So our similarity ratio, again, you want to look at corresponding angles help you, but I could say B, C, D, E would be similar to, and it would be Z, W, X, Y. Okay, the second one's a little bit harder. So the first part's not. Angles are congruent. Well, they're all right angles, so that's a definite yes. We got that taken care of. 2, side lengths are proportional. So this one's not as obvious because all the angles are the same. So a little trick that you can use is whenever you're looking at possible similar triangles, the smallest side here on one shape would have to correspond with the smallest side on the other shape. So the 4 would have to go with the 3, especially since they're a rectangle. So I'm going to write this as 4 to 3. And then the bigger side would have to go with the bigger side. So that's going to be 6 to 5. Now, those are in reduced form and they are not the same. So that's a no. So these are not similar. Okay, another way you can prove that the proportion is not the same is if you cross multiply. You get 18 and here you get 20. That cross product does not work. So that's another way you can look at it. Okay, so on the next one, whenever you're given a similarity statement, pay attention to it. I would even circle it, box it, but highlight the fact that you are given a similarity statement because that will make your life a lot easier. So you know exactly which sides correspond. So in order to find the similarity ratio, you want to figure out two sides or two corresponding sides that both have numbers on them. So I see AC here is 18, and then QS has 12. So those two both have numbers on them, so I know it's going to be 18 to 12 from the big triangle to the small triangle, because that's what this is, big triangle to small triangle. Okay, but again, we generally reduce it first of all, but we also write it as a fraction. So this is going to be 3 to 2. Okay, solving for all of these variables. A, B, and C are angles, so just keep in mind that angles are congruent. So you're not going to use the similarity ratio for the angle piece of this. Okay, so angle C goes with angle S. Those aren't obvious, so let's try a different one. Angle A goes with angle Q. So I know this is going to be 50. And the degrees is already marked there. B, oh, that's confusing. So B is here. So the B goes with the R. So that's going to be 60. And then you'll have to use the triangle sum theorem to figure out C, because neither C or S are labeled. So here, that's 110, so this would have to be 70, add up to 180. Okay, second, doing all of these, the side lengths, you are going to use that similarity ratio. So big triangle to small triangle. So big triangle 12 BC goes with RS, which is X. So that's 12 to X. And then Y would have to go with the 10. So AB goes with QR. So Y over 10. Okay, we're about to run out of time. So what you're going to do is use this to solve for X and Y. and then we'll talk about it when we return to class.